Welcome back to the deep dive. So if you're like most of us building AI systems today, you've probably felt this pain, whether it's a simple RAG pipeline or a really complex AI agent. You spend maybe 80% of your time just wrangling data and only 20% on the actual AI magic. Today, we are going deep on the foundation. It's what a lot of experts are calling the single biggest missing piece in the whole enterprise AI stack, and that is data preparation.
It really is the silent killer of RX systems. I mean, we've seen incredible innovation in the models themselves, right? They get smarter every single way. But organizations are hitting this critical ceiling. They're constantly trying to feed these brilliant models just dirty, context-poor data from, legacy systems and ancient document formats.
Right. So our mission today is pretty simple. We want to give you the blueprint for actually fixing that data problem. Because for an LM to give you a truly accurate, trustworthy response, you have to fully understand the context, the structure, the hierarchy of the information you feed it.
And here's the unavoidable truth. For anyone, really, in a data-heavy organization, your most critical information is overwhelmingly unstructured. We're talking about huge archives of PDFs, old Word files, PowerPoints, endless spreadsheets, scanned images, even audio files. And they're all just islands of context. They're not natively readable by an LLM in any useful hierarchical way.
And just trying to force that messy reality into a neat digital format, that's where these projects just fall apart. Which is exactly why we're focusing on Docling today. It's an open source framework, and it's designed to take all those varied, unstructured sources and convert them into clean, machine-readable formats like structured Markdown or plain text or JSON, things that a large language model can actually use in a scalable workflow.
Yeah, that's the core idea we're really unpacking. The real barrier to success in RAG or agentic AI. It isn't the complex model itself, it's the tedious, error-prone grunt work of curating the knowledge behind it. Docling is built to automate that grunt work.
Okay, let's unpack that transformation process then. You mentioned all these different file types. Why is standard data conversion, the kind of thing we've been doing for years, so hard when the output is for an LLM? I mean, we've had optical character recognition, OCR, for ages now.
Right, but standard OCR is just a first step, and honestly, it's brutally insufficient for complex documents. OCR just gives you a wall of text. It doesn't tell you, hey, this text is a table header, or this paragraph belongs to section 3.1. If you try to run complex documents, with tables, bullet points, nested sections, you spend weeks, developer weeks, writing custom parsers just to get something moderately useful. Docling is purpose-built to handle all of that. Variety PDFs, Word, PowerPoint, scanned images, spreadsheets, and convert them directly into the rich, structured formats you need.
So it's not just recognizing the letters on the page. It's about respecting the entire document layout, the semantic meaning. And speaking of agentic workflows, we have to talk about the Model Context Protocol, or MCP. It sounds like a really heavy piece of technical jargon, but why is it so critical for modern AI agents?
It is a dense term, I'll give you that, but the function is actually pretty straightforward. MCP is an open standard. It's designed specifically to let AI applications integrate seamlessly with external tools and data sources. Think of it like a universal API gateway for agents. It's essential because agents aren't just one piece of code anymore. They need to use tools. Go look up this data or go process this file.
That makes a lot of sense. The agent needs a standard way to ask for resources. So how does Docling, which is doing this conversion, become one of those tools in the agent's tool belt through MCP?
Docling can run as a fully functional MCP server. You can host the server locally, and it plugs right into your favorite desktop clients or dev environments, things like the Claude Desktop app or LM Studio or Cursor. And the workflow is incredibly clean. The AI application, the client, makes a call, often just in natural language, to the local Docling MCP server. The agent can basically just say, I need you to take this PDF, pull out the sales figures from it, and convert the whole thing into Markdown.
I see the immediate win there. The conversion happens right on your machine. The agent gets back clean data. But let me ask a critical question. Doesn't adding another layer, this MCP server, potentially add complexity? Or maybe latency compared to just running a script?
That's a great question, and it gets to the heart of why standardization is so powerful. Yes, you have a server, but it's optimized for one thing: rapid document processing. the complexity is actually reduced. You're not writing custom Python logic for every single file type anymore. You're relying on a robust standard framework. And because of that MCP standard, any LLM or agent that supports tool calling can use Docling for conversion across hundreds of formats just by understanding one protocol. It abstracts away all the messy, error-prone stuff.
That standardization is absolutely key for scaling and for making sure the conversion logic doesn't become the weakest link. So once we have this wonderfully clean, structured output, the immediate payoff has to be downstream. And nowhere is that more true than in our gab pipelines. If you're just throwing massive text blobs into a vector database, you're not getting good results.
You're not just missing the plot. You're actively creating bad context for the LLM. The standard practice, is fixed size splitting. You take a 1,000-word document and just chop it into 10 100-word chunks. When you do that, you often cut a table in half, or you separate a caption from its figure. Or even worse, you retrieve a paragraph that has completely lost the section heading it belongs to.
So the LLM gets this seemingly random piece of text and has no idea what chapter or title or even what document it came from.
Exactly. And this is the aha moment with Docling's output. It generates a rich hierarchical Docling document. This output isn't just text. It meticulously includes element types, headings, and crucial per-element metadata. It defines the document's real structure.
And why does that hierarchy make such a big difference for RAG's quality?
Because it provides structure where standard chunking is totally blind, Docling lets you do smart chunking right out of the box, splitting documents logically by sections, tables, captions, and critically, it automatically carries the parent context, the titles, the chapter numbers, the headers down into every chunk. So when you retrieve a paragraph, the LLM immediately knows the source, the section, the topic, because that context is baked right into the metadata. The retrieval signals are just vastly superior to those fixed size splits.
And this is where it starts to feel really modern. Multimodal RG. Most important business documents aren't just text. They have charts, images, figures that are critical to the meaning.
Absolutely. Docling fully enables a multimodal RG setup because those images and tables are preserved during conversion. They don't just vanish. And what's more, there's an optional enrichment layer. Figures can be automatically enriched with text descriptions. Those descriptions then get indexed right alongside the text, which makes those crucial visuals retrievable context, not just decoration.
That dramatically increases the depth of what you can retrieve. But let's turn to the biggest hurdle in enterprise AI adoption, which is trust. If an LLM gives me an answer based on, say, a 2-year-old internal report, how do I, as a manager or a compliance officer, trace that back to verify it, to make sure the AI didn't just make it up?
You've hit on the absolute core of why unstructured data handling has failed in regulated spaces. The answer is provenance. In Docling's output, every single element, every section, every table cell, every figure description includes detailed provenance, page, and bounding box information.
Walk us through what that means in practice. What does that bounding box detail actually let a user or a developer do?
It lets you build a fully auditable system. That bounding box info, the exact coordinates of the text on the page, means that when a span of text is retrieved, you can visualize exactly where it came from. Your application can literally overlay highlights back onto a rendered version of the original PDF. It can link directly back to the source page, lets you instantly review the result. This transparency it drastically increases trust. It bridges that gap between AI aspiration and real-world enterprise compliance. You don't just trust the AI, you can trust and prove the source data.
That completely moves the conversation from, did the AI hallucinate, to show me the page number and the highlight. That is a fundamental shift. Let's pivot now to another huge, expensive pain point for businesses: extracting specific structured data, from invoices, purchase orders, financial reports. This is where companies spend countless hours on manual parsing or building brittle custom software.
Exactly, and that manual effort is only necessary because of the lack of structure. Like we said before, typical OCR just returns text. You get a huge block of words and numbers, and the system has to guess which number is the invoice total and which one is a zip code. It's so error-prone.
And when a system guesses wrong, the downstream API that needs an exact dollar amount or a specific date format just crashes.
Precisely. That's the vulnerability. But with Docling, you get the rich hierarchy and the semantic understanding of the document. And that enables its information extraction feature. You can define a template or a specific data schema, say a pydantic model in Python, with the fields you need.
Hold on, for our listeners who might not be deep in the Python data stack, what exactly is a pydantic model? Why is using it here so powerful?
Great question. Pydantic is basically a way to guarantee the shape and the type of your data. So instead of just hoping your extractor returns the cost as a number, you define a schema that says the total cost field must be a floating point number and the date issued field must be a valid date format.
So you're not just defining what you want, but the exact format and data type it has to be.
Exactly. Docling then uses its understanding of the document hierarchy to fill that schema. It gives you clean, validated, structured data that matches your scheme. And this is a massive deal because it gives you type safety and validation right from the initial PDF. You're turning unstructured data into truly structured, schema-compliant output that's ready to feed directly into your APIs, into your RAG pipelines with no messy cleanup scripts. It guarantees data quality at the source.
It accelerates everything because the data isn't just extracted, it's pre-validated, it's guaranteed to be usable. It cuts out that frustrating middle step where you find errors only when the data hits the next system in the chain. Now, Docling sounds amazing on its own, but in the real world, it has to play nice with the existing AI and data ecosystems people are already using.
And it integrates seamlessly because the output is standardized. Dockling's outputs drop directly into all the major RG frameworks people are using today. LangChain, LlamaIndex, Haystack, LangFlow. The documents that come out are those rich, contextualized markdown chunks ready for retrieval and prompting within those familiar tools.
So if a developer is using LangChain, they're just ingesting Dockling's output as their document loader.
Correct. And that simplicity goes beyond just the framework. We're seeing teams wire Dockling into their bigger data pipeline automation for both batch processing and real-time ingestion. The beauty of the approach is that the core parsing logic Dockling stays the same. Everything else, the hierarchical framework, the vector database, the LLM you're using, that just becomes a configuration choice. This growing ecosystem means way less custom glue code for developers to write. You parse the document once, perfectly, and the rest of the stack is just configuration you can swap out later.
That flexibility is absolutely key, especially for large organizations. Okay, finally, let's talk about governance and long-term viability. When you're dealing with sensitive, regulated data, especially in healthcare or finance, big companies require on-premises systems. They demand extreme transparency. And open-source solutions can sometimes raise red flags about stability or security.
This is where Docling has a huge strategic advantage over proprietary vendors. Not only is it open source under the very permissive MIP license, which ensures full transparency, but it's also governed by the Linux Foundation Data and AI Foundation.
And that Linux Foundation backing really changes the conversation around enterprise adoption, doesn't it?
It completely does. It provides that stamp of institutional legitimacy that conservative enterprises need. They need governance, they need auditability, and they need to know the framework won't just disappear or change hands. Plus, so many of these regulated industries require on-prem systems. They can't just send their most sensitive documents to a cloud API or a black box solution. Docling provides a transparent, secure, self-hostable framework that meets those rigid compliance needs perfectly.
It sounds like it removes the major risk factors you'd get with a proprietary closed-source solution in those high-stakes environments. Okay, let's wrap this deep dive up. We've covered how Docling solves that foundational problem of data prep by respecting document hierarchy, how it enables seamless agent integration through that standardized MCP server, and delivers far superior RAG signals through hierarchical chunking and verifiable provenance. And crucially, how it provides type-safe information extraction and the enterprise security needed through its open-source governance under the Linux Foundation.
And if we connect this to the bigger picture, its position as an open-source standard under the Linux Foundation, designed for these secure on-prem deployments. It raises a really important strategic question for every large company building AI. Given the inevitable demand for full transparency and verifiable provenance in enterprise AI, how might an open-source standard like this influence or maybe even accelerate the future adoption of proprietary closed-box AI agents and RAG solutions in these large conservative enterprises? Is this kind of standardization and audited provenance really the future of enterprise AI infrastructure?
Something for you to mull over as you optimize the data quality in your next RAG pipeline. Thank you for joining us for this deep dive.